In this video, you're going to learn everything you need to know about exception handling in Java. So by the end of this video, you'll be able to write Java code with confidence. Hi, I'm Mosh and I've taught millions of people how to code through this channel and my online school, codewithmosh.com. This video is part of my ultimate Java mastery course, so once you finish this video, if you want to learn more, you may want to look at the complete course. Now let's jump in and get started. Let's start this section by a quick overview of exceptions. First of all, I'm going to add a package in this project. I'm going to write all the code for this section in this package. So let's add a new package called exceptions. As you can see, I've created packages for the other sections of this course. You can find all these packages and all these files in the zip file that I gave you at the beginning of the course. Now, in the exceptions package, I'm going to add a new class called exceptions demo. This is where I'm going to demonstrate concepts. Here I'm going to add a public static void method called show. I made it static so we can call it easily from the main method without having to create an object. Okay. Now let's go to the main method and call exceptions demo.show. Now back to the demo class. I'm going to create another static method, public static void say hello. We give it a parameter of type string called name. And here we want to print name in uppercase. Pretty straightforward. Now, in the show method, I'm going to call the say hello method and pass null, which represents the absence of a value. Now, when I run this program, our program is going to crash. Let me show you. So our program crashed. We got an exception or an exceptional event. And the type of this exception is null pointer exception. This is the root cause of many problems in Java programs. Now, this null pointer exception is a class that is declared in this package, java.lang. So an exception is an object that contains information about an error. In this case, this object is an instance of the null pointer exception class. Now we have several exception classes in Java, and you'll learn about them as we go through this section. Now let's see where this exception occurred in our program. We got this exception in the say hello method on line 9 of this file. If we click, we can go to the offending line. So this happened when we tried to call the toUpperCase method on null. That is why we got a null pointer exception. Now, how did we get here? We got here from the show method on this line. Okay, but how did we get to the show method? We got here from the main method. So this information that we have here is called the stack trace. It shows the methods that have been called in the reverse order. And this is very useful when troubleshooting problems. We can see exactly how we got to the offending code. Now, back to our say hello method. When an exception occurs in a method, we say that method threw an exception. Just like how a person can throw a ball, a method can throw an exception. Now, when this happens, the Java runtime looks for a block of code in that method for handling that exception. We refer to that as an exception handler. In this implementation, we don't have any exception handling code. I'll show you how to add that later. So the Java runtime looks for an exception handler in this method. If it doesn't find it, it goes to the previous method. That is the show method here. Again, we don't have any exception handling code here, so the Java runtime goes back to the main method, hoping to find an exception handler. We don't have one here, so that is why the Java runtime terminates our program and displays the exception. Now, as a good Java developer, you should prevent such exceptions from happening or anticipate and handle them properly. And that's what you're going to learn in this section. In the next video, we're going to talk about the different types of exceptions. In Java, we have 3 types of exceptions: checked exceptions, unchecked exceptions, also called runtime exceptions, and errors. A lot of people new to Java find this confusing, so let me make it super simple for you. Checked exceptions are exceptions that we developers should anticipate and handle properly. For example, let's say we want to read data from a file. What if the file doesn't exist? Maybe it got deleted just before we tried to open it for reading. Good developers always anticipate and handle these edge cases. So instead of letting the runtime terminate our program, we would better display a friendly message to the user saying, hey, that file doesn't exist. Now, the good news is that the Java compiler enforces us to handle these errors. That is why they're called checked exceptions, because they get checked at compile time. Let me show you. Let's create a new file reader for reading data from a file. So reader equals new file reader, let's say file.txt. Now look at this red underline. The Java compiler knows that the constructor of the file reader will throw an exception if the file doesn't exist. So it's telling us, hey, you haven't handled this exception, file not found exception. This is an example of a checked exception. So checked exceptions are exceptions that we should anticipate and recover from, and that is why they're called checked exceptions, because the Java compiler checks them at compile time. Now, the second type of exception is called unchecked exception or runtime exception. As the name implies, these exceptions are not checked by the compiler at compile time. They occur because of programming errors. Null pointer exception is an example of a runtime exception. In the last video, we shouldn't have passed null to the sayHello method. This is a programming error. So unlike checked exceptions, we don't want to anticipate and recover by displaying a friendly message like, hey, we made a mistake and tried to use an object reference with the null value. Doesn't make sense. Instead, we should prevent exceptions like this from happening in the first place. How can we do that? By good coding practices and testing, a lot of testing, preferably automated testing. Now, that's a topic for an entirely different course. Now, other examples of runtime exceptions are arithmetic exception. This gets thrown if we try to divide a value by 0. We also have illegal argument exception for indicating that the argument we passed to a method was not accepted. Again, this is a programming mistake, not a kind of error that we should anticipate and validate. Another runtime exception you may see is the index out of bounds exception, which occurs if we try to access an element in an array or a string or a list using an invalid index. For example, we have 5 elements in an array, but we try to access the 10th element. Another popular runtime exception is illegal state exception, which gets thrown if we try to call a method, but the underlying object is not in the right state. So these are runtime exceptions. The third type of exception we have in Java is an error, which indicates an error external to our application. Examples are Stack Overflow error or out-of-memory error. So if the Java virtual machine runs out of memory, there's nothing we can do about it. So just like runtime exceptions, we should let the application crash rather than display a friendly message to the user. We should try to identify the source of these errors. These errors can happen because of programming errors, like an infinite recursion, or for reasons outside of our application, like a problem in the Java virtual machine itself. Next, we're going to look at the hierarchy of exception classes in Java. Now let's look at the classes that represent different types of exceptions. At the top of the exceptions hierarchy, we have the throwable class, which defines the common characteristics for all exceptions and errors, like an error message and the stack trace. So every kind of exception or error has an error message and a stack trace. Below this class, we have 2 classes, exception and error. The error class and all its subtypes represent errors that are external to our application, like out-of-memory error. The exception class is the parent for all checked and unchecked exceptions. Below this class, we have the runtime exception class, which represents runtime or unchecked exceptions. So if an exception class derives from the runtime exception, it's considered an unchecked exception. Otherwise, it's a checked exception. I know, this is a bit weird because we may think that any classes that derive from the exception class is a checked exception. So runtime exception should also be a checked exception, but that's not how it works. Why? Honestly, I have no clue. You have to ask the developers of Java. So let's quickly explore this hierarchy in Java documentation. So we search for Java null pointer exception. Here's the documentation on oracle.com. All right, look at the exception hierarchy. So here we have the null pointer exception. This class derives from the runtime exception, which derives from the exception class, which in turn derives from the throwable, and as you can see, the object class is the parent of all classes in Java. Now, if you're curious what other runtime exceptions we have, you can go here, and under direct known subclasses, you can see all types of runtime exceptions. Now, you don't really need to learn about each of these individually. You will get to know them as you build Java applications. Some of them may never occur to you. So don't worry about learning all types of exceptions in Java. Next, I'm going to show you how to handle exceptions. Now let's see how we can catch exceptions. So let's create a file reader object. Reader, we set it to a new file reader. And here we type file.txt. The name doesn't matter. Now, right after this line, we print a message like file opened. Now we have a compilation error because we haven't handled the file not found exception. To do this, we should wrap this code inside a try block. So we type try followed by curly braces to indicate a block of code. Then we move these lines inside this try block. Now, right after the try block, we type the catch clause. And here in parentheses, we specify the type of exception we want to catch. In this case, file not found exception. Then we give it a name. By convention, we call this object X, as in short for exception. So this X object is an instance of the file not found exception. It's an object that contains information about this exception. So here we add another block. And in this block, we print a friendly message to the user. Something like file does not exist. Now, let's run the program. Our program didn't crash. This is the proper way to handle checked exceptions. Now, we can also get the message from this exception object. So we type x.getMessage. This returns a string, so we can print it on the terminal. File.txt, no such file or directory. This error message is defined in the file not found exception class. Okay. Now, what happened to this statement over here? We tried to print file open, but we are not seeing that message. Here's the reason. When a line throws an exception, the control moves to the catch block for that exception. So the code that we have after the offending line will not be executed. However, if I take this line and put it after our try catch block, it will get executed. Take a look. So now we have file open. So this is how we can catch exceptions in Java. Now let me show you a trick. I'm going to take this line out of our try block, put it over here, and then delete the rest of this code. So let's say we are creating a file reader object and the compiler is complaining that we haven't handled this checked exception. Now, we don't have to manually type a try catch block. We can put the caret over here, press Alt and Enter, and select surround with try catch. Isn't that beautiful? So IntelliJ automatically created this try catch block for us. Now here we're calling the print stack trace method of this exception object. This will show us something like what you saw before. So we got an exception of type file not found exception. Here's the error associated with this exception. Now look at the stack trace. This exception was thrown from the file input stream class. This is not part of our project. This is part of the standard Java library. So in our show method, when we tried to create a new file reader, the constructor of the file reader was called, and then internally, this class works with another class called file input stream. Here we have a few method calls, and this is where the exception was thrown. So sometimes you see a long stack trace because of the method calls in the Java standard library or other libraries that you use. Next, we're going to talk about catching multiple types of exceptions. Sometimes we need to catch multiple types of exceptions. For example, after reading a file, let's call reader.read. This reads one character and returns its numeric value. So let's store it in a variable called value. Now here we have another compilation error because we haven't handled the IO exception. So this read method may throw an IO exception if it cannot read data from this file. To solve this problem, we need to type another catch clause here. So catch, like here we want to catch an IO exception. We give it a name. And in this block, we can print a message like could not read data. The exception is gone. Now we have multiple catch blocks, and each catch block targets a specific type of exception. So only one of these will be executed. In this case, we try to open a file that doesn't exist. So this line will throw a file not found exception, and this catch block will catch that exception. Now, the code inside this catch block will get executed, and after that, the control will move over here. So this second catch block will get ignored, okay? So we have multiple catch blocks, and each catch block targets a specific type of exception. Now, does the order of these catch blocks matter? Sometimes it does. So if I move this catch block over here, you see a compilation error. The Java compiler is saying that we have already caught the find not found exception. What does this mean? Well, let's look at the documentation for the find not found exception class. So we type Java file not found exception. Here it is. Okay, so this class extends the IO exception class. And that means if we have a catch clause for an IO exception, we don't need this find not found exception. This is the polymorphism principle of object-oriented programming. We talked about this in the second part of this course. Let me show you. If I have a variable of type IO exception, let's call it X, I can set this variable to a new instance of IO exception or any classes that extend the IO exception class. So we can set this to a new file not found exception. This is polymorphism. An object may take different forms. So if you have a catch clause to catch an IO exception, this catch clause can catch an IO exception or any of its derivatives, any classes that extend the IO exception class, okay? Now, sometimes we want to treat these exceptions the same way. For example, here we can display a generic error message, but other times we want to handle them differently. If that is the case, then we need to bring back this catch clause and put it before the first catch clause. So now if we get a file not found exception, we can print a message like file does not exist. So we are giving the user a more specific error message, okay? Now, as another example, let's create a new simple date format object and call the parse method. Now here we have another compilation error because this parse method may throw an exception of type parse exception. Now we can put the caret over here, press Alt and Enter, and have IntelliJ add a catch clause for us. There you go. So it's right here. Now we have 3 catch clauses. Let's say we want to treat all of these the same way. So first we can get rid of the file not found exception. Now we have 2 catch clauses. We can combine this using a vertical bar. So right after IO exception, we type a vertical bar, then we type parse exception. And with this, we don't need the second catch clause. So this block can catch exceptions of type IO exception or parse exception. So these are different ways to catch multiple exceptions. The approach you take really depends on your application and its requirements. Next, we're going to talk about the finally block. Let's imagine this file exists. So we successfully open it for reading, but something goes wrong when we try to read data from this file. This could happen because of a hardware problem. Now we have a problem in this code. The problem is that we have opened this file for reading, but nowhere we have closed it. File handles are operating system resources, so whenever we get them, we should always release them. Otherwise, other processes may not be able to access these resources. So somewhere in this code, we should write reader.close. Now, there's a problem with this implementation. Can you tell? The problem is that if this line throws an exception, the runtime will pass the control to this catch block, so this line will never get executed. Now, what if we put this line after our try catch block? Now the reader variable is not recognized because we have declared it inside this try block, so it's only accessible in this block. But let's not worry about it for a second. The problem with this implementation is that sometime in the future, another developer might come here and write some extra code, and this code may throw an exception. Again, our reader is not going to get closed. The proper way to handle this kind of scenarios is to use the finally block. So right after the catch block, we type finally. Now in this block, we can release external resources like file handles, database connections, network connections, and so on. So here we should type reader.close. But once again, reader is not recognized because it's only accessible in the try block. To solve this problem, we need to declare this before our try block. So we type file reader, and then set it over here. And by the way, we cannot use var over here because we can use var only when we set this to a new instance of a class. So the compiler knows that this object is an instance of the file reader class. In this case, we're not initializing this variable. So the compiler doesn't know what is the type of this variable, okay? So let's type file reader. Now, we have a compilation error. Variable reader might not have been initialized because in Java, before we can access an object, we should always initialize it. So if this line doesn't get executed, if it throws an exception, we'll try to use an uninitialized object. To solve this problem, we need to explicitly set this to null. The compilation error is gone. Now we have a different kind of error. We'll talk about that in a second. But first, let's add an if statement. We want to call the close method only if the reader is not null. So if reader is not null, then close it. But what is this compilation error? Unhandled exception, IO exception. So the close method may also throw an IO exception. To solve this problem, we need to wrap this inside the try catch block. So we put the caret over here, press Alt and Enter, and then surround with try catch. So here's the final result. Now, this code looks really ugly. I have to admit that we have a much better exception handling structure in C#. Now, that aside, what I want you to take away here is that this finally block will always get executed, whether we have an exception or not. If we don't have an exception, all the code inside the try block will get executed, and then the runtime will pass control to the finally block. If one of these lines throws an exception, one of our catch blocks will get executed, and then the finally block will get executed. So the finally block will always get executed no matter what. Now, this implementation is really ugly. In the next video, I'm going to show you a better way to release external resources. Thank you so much for watching this video. As I said, this video is part of my Ultimate Java Mastery course that teaches you everything you need to know about Java from the basics to more advanced concepts. So if you want to learn more, I highly encourage you to take the full course. It's much faster than jumping from one tutorial to another. If you're interested, the link is below this video. Thank you and have a great day.